Hello?
Hello?
Shalom?
Shalom? Konnichiwa?
No, let's not go there.
No?
No,
Okay.
not today. Where's Bo?
Huh? I don't know. Donkey shake for those other people? Okay. Alright, now. Okay, so that's what we're doing. Finding absolute maximum and minimum values. Find the absolute maximum values and absolute minimum values of the function. Okay, so endpoints. So we need to do endpoints for each, right? Okay. So first, find the derivative. What's the top one? What's the derivative of the top one?
2.
2. Okay, derivative of the top one's going to be 2. So let's call this one F here and call this one G. All right. For those people playing along at your home version of the game, hold on. All right. Okay, there we go. All right. Okay, so we're back to it again. So now that's F, that's G. So let's see, F prime is 2. G prime would be 2x minus 5, right? So if I set F prime equal to 0, I don't get 0 and 2. No. So I'm not going to have any places there where it's going to be equal to 0. Now, if I do this one right here, it's going to be 0 equals 2x minus 5. So x would equal, that's an ugly one right there, minus 5. So x equals what? 5 over 2. 5 halves. So I have 1 there now, right? Okay, so let's check the endpoints of my first one. So for this one, it's going to be, so f of 0, right, is going to give me -1, right? Okay, so let's check the other one. So f of 2, f of 2, Three? You agree? 3? Because you're plugging in 2 to this, right? So 2 times 2 is 4, minus 1 is? There we go. Okay, so that one's from my f. Let's do the g part. So all this is part of my f of x right here. So I just broke it up into different parts just to call it that. So it's called g of, now, do I do 2?
No.
Why?
It's not included.
It's not included, so I can't include that point, right? So I'm not going to do 2, but I am going to do 3, and I also have to do 5 halves, right? So what would make this really easy? That 5 halves. I can plug that in the calculator too, right? So that would be 25 over 4, right? Let me see. Let's see if I can get this. All right, so 25 over 4 minus 5 halves, that's 25 over 2, plus 9. So let's see, that's going to be 25 over 4 minus 50 over 4 plus, that's going to be 36 over 4. So it's 25 plus 36 is 61.
16.
16?
Wait, what?
Wait, hold on. You're right.
Wow.
No, because, yeah, that's negative. Okay, so, what do I get?
11.
16? 11? See, 25. Yeah, you're right. 11 over 4.
Wow.
Which is, I know, right? I'm telling you, that coffee's still full.
I think that's just candies
Candy? Is that dessert of candy? Is that what it is?
for everyone.
For everyone?
For everyone.
I know. For everyone that made it to class today gets a candy.
Yeah.
All right.
Oh. No, I'm just kidding.
All right. So 1104. Give me a decimal approximation of that. 1104 is what? 2.5. point
2.75.
2.75. Right? So there we go. 2.75. All right, that's not too bad, right? Okay. So, all right, I got that one. And next one, 3. Plug in 3. So G of 3. G of 3 is going to give me, let me see, 9 minus 15. 9 minus 15 is going to give me what? Negative 6 plus 9, positive 3.
That's what she said.
Okay. Who am I to call you a liar? All right. So, what's my minimum?
F is 0.
F of 0. So I'm going to have a min at 0, right? And I have a max where?
At 3.
At,
G of 3.
yeah. So G of 3. So when I plug in 2, so I'm going to have a max at here at 2 different places. So I'm going to have, let's see, let me write this out. So it's going to be 0, comma, negative 1 is my min. And then my max is going to be at 2, comma 3, and again at 3, comma 3. Okay, same value. ¿Está muy fácil? Sí. Es muy caliente. All right. All right, so rain gutter, okay, is to be constructed by using a piece of aluminum 12 inches wide after marking a length of 4 inches from each end. So here it is right here. So bam, bam, there's right there. The piece of area of a cross section opening expresses the function of theta as the area of theta is equal to 16 sine theta times cosine theta plus 1, and my interval is going to be from 0 to 2 pi. Or I'm sorry, 0 to pi over 2. Now, think about it. What is pi over 2 anyway? Where is that straight up? Thinking you're going to circle. That's straight up, right? That's 90 degrees, isn't it? Okay, that's perpendicular. That's what I'm thinking about. Okay, in 0. Do you think I'm going to have much, is it going to hold much water with an area of 0? Say no. No, it's not going to hold much water in that area, right? Okay, so I'm going to maximize the area. That's what I'm trying to do. Trying to maximize the area for there, right? So to do that, I'm going to get a min or max on this. So I need to take the derivative and set that equal to 0. So this one already gives you a function. So we're good here. So let's say, so a prime, so it's going to be a, what rule for this? What rule?
Chain. No, it's not chain.
Is it product?
It is product.
Okay.
It is product. There is a multiplication right here. It's product. Chain would be if I had an exponent on this also. Right? Okay. All right, let's keep going. So let's call this one F, call this one G. So I am going to another slide on this one. Let's see right here. Insert page after. Okay, so what do we say? So it's A of theta is equal to 16 sine theta? Cosine theta, was it plus 1 or minus 1? Like that, right? There we go. So, like I said, I'm calling this F and calling this G. So F prime, what's F prime? What's the derivative of sine theta?
Cosine.
Very good, cosine theta. But what's in front of it? 16. So it's going to be 16 cosine theta. Next one's going to be G prime. What's the derivative of cosine? what's going to happen to that 1 right there, that plus 1?
It's gonna disappear.
It goes 0, right? That goes off. So the derivative is just going to be a negative sine of theta. Product rule says f prime g, then g prime f. So it's going to be 16 cosine theta times cosine theta plus 1 plus g prime, which is going to be g prime f. So it's going to be let's see. I'm going to put the f first though. 16 sine theta times negative sine theta. Hate running out of board. That bugs me. There we go. Okay. So I have everything there now, right? So yes. Okay, let's go with it. So I'm going to do some distribution right here. I'm going to distribute this here. So it's going to be 16 cosine squared theta plus 16 cosine theta, right? Because I'm distributing to both. And this is going to multiply to be minus 16 sine theta.
Not squared.
Oh yes, squared. There you go.
Can you?
All right. Okay, so what is the issue with this? I could actually try and solve for this, but I got a slight issue. What don't I like out of this?
You get the
Come on. What part of this makes it messy?
square and 16 and everything. I just don't like the sign.
Can you combine the
Everything
16
is messy
cosine
right
squared
now.
and the 16 cosine?
I could, but there's an issue with it. Since it's a positive and a negative, that's not going to help me out.
It is?
Yeah, right here. So what's cosine squared plus sine squared? What's x squared plus y squared? It's an identity.
R squared.
R squared, which is just
The
1. So if you have sine squared plus cosine squared, you can get 1. But this is a minus, and that's my issue. That's what I'm trying to say. My sine is my issue here. The sine is the issue. I can't factor it out because I have sines and cosines. I want everything to be in one term. I want everything to be in cosine. Is there a way to replace sine squared with something else?
Is
Yeah.
that an identity?
1 plus cosine or something.
Yeah, okay, there we go. So let's take a look at it. We know that, watch this. So x squared is cosine squared, right?
Mhm.
Plus y squared is sine squared, right?
Mhm.
Equals 1. This is the Pythagorean identity. Okay, we get this from the unit circle. Your x value, your y value, your cosine is always your x, your sine is always your y. So I'm going to make it into y squared equals something. So I could replace, so let's subtract x squared from both sides. So now I can get y squared is equal to 1 minus x squared. So in trigonometry terms, what does this actually say? What does this say?
Sine squared?
Sine squared is equal to
1 plus cosine squared? Or
1 minus cosine squared. That's what that says. So in trigonometry terms, that is sine squared is equal to 1 minus cosine squared.
So
Okay, if you don't have it on your paper, you should have that. So I'm going to replace, because I want, there you go. Okay. So I am going to replace this. So I'm now going to replace this. So now it's going to be, bring it down, 16 cosine squared theta plus 16 cosine theta minus 16 parentheses. And what did I say I'm replacing sine squared with?
Cosine squared. 1 minus cosine squared.
1 minus cosine squared. So 1 minus cosine squared theta. All right, so now from here I have to, starts with D, ends in distribute. Yeah, let's distribute, okay? I gotta distribute. So it's gonna be 16 cosine squared theta plus 16 cosine theta minus 16, right? And then plus 16 cosine squared theta. Now can we combine like terms? Now I have like terms. Now I could actually put this stuff together.
Yeah.
So I'm going to do that. So I'm going to have how many cosine squareds?
2.
Not 2. How many's right here?
42.
Yeah. Okay.
You have this, right?
32.
Yeah, you're going to have 32. You're going to have 32 because you have 16 here and you have 16 over there. So together we're going to have the 32.
That's what I mean.
So 32 cosine squared theta plus 16 cosine theta minus minus 16, right? So now from here I could factor. It is a trinomial. It is a trinomial, and with this trinomial you're factoring it. So we know that cosine is just x, right?
Yeah.
Okay, so let's actually just think of it like that. If you think of cosine as x, can't we just rewrite it as 32x squared plus 16x minus 16? And all of this is my derivative, right?
Yeah.
So this is the derivative. So x equals cosine theta, right? And this is the derivative, so it's right here. So now from here, I'm going to say this, if I set that equal to 0. So I did some interesting math. Did I lose anyone? Do you like changing your cosine to just x's? It makes the algebra look easier, doesn't it?
Yeah.
So if you change that to x's, or if it was all sines, you would change it to y's, right? So it makes the math come out a whole lot easier. Now we got to factor that trinomial. So what am I taking out of?
16.
I'm going to take out a 16, right? So if you factor out a 16, all right, I'm running out of board space, so insert page after current. So it's going to be 16 parentheses, and that's going to be 2 it's not cosine anymore, it's x's.
So x squared plus x minus 1
X squared
plus x
plus x
minus 1.
minus 1. Okay, that's from the previous, right? Because I took out a 16 from both of those. So I had a minus 1 and I had a just 1x there. Now can I factor that? That is a trinomial now, right? So I'm going to do the AC method real quick. So 2 times negative 1 gives me negative 2. What are the factors of negative 2 that add together to be positive 1?
Negative
How about positive 2, negative 1, right?
2, negative 1, yeah.
Yeah, positive 2, negative 1. So positive 2, positive, come on, Come on, you can do it. You can do it. Ah. Oh, there we go. Minus 1 equals 1. There we go. This board is on its, like, dying already. I know, right? So weird. It'll tap here, but it won't tap where it's supposed to tap. All right, so it's going to be 2 minus 1 is equal to 1, right?
Yes.
So I'm going to replace my middle term with this, so I can factor it now. So let's already take care of that 0, or the 16.
Divide.
Yeah, divide both sides by 16. What is 0 divided by 16?
0.
0. So the 16 just goes away now, doesn't it? So let's see. So it's going to be, let me see, 0 equals, so that's 2x squared plus 2x minus 1x minus 1, right? I just replaced my middle term here with these right here. So now, factor, common factor here. So I'm going to take out a 2x. I'm left with a x plus 1. I'm going to take out a negative 1 from here. I'm left with x plus 1. All that's still equal to 0. 0 is equal to x plus 1 and
2x minus 1.
very good. But what do we say x is? X is going to be what? Cosine. Now let's put it back. So we did all of our factoring because our algebra looks a whole lot easier like this than with the sine and cosine, right?
Yep.
Okay, so I'm going to put it back. So now it's going to be 0 is equal to cosine theta plus 1 and 2 cosine theta minus 1. Now I'm going to do zero product here. Zero product says here, so this is going to set equal to 0. So 0 equals cosine theta plus 1. Subtract 1 from both sides, so negative 1 equals cosine theta.
We're doing the same thing for the other part?
Yeah, we're going to do the same thing to the other side too. But now, what this is asking is, where is cosine equal to negative 1? Where is cosine equal to 1? So right here, now this next thing is called the arc, or the inverse. It's where I'm going to switch the theta and the negative 1. So it's going to be theta inverse cosine, or arc, of negative 1. So on my unit circle, where is cosine equal to negative 1?
Inverse cosine?
Where is cosine equal to negative 1? So think about the x values. Where is the x values equal to negative 1? So if you guys need to pull out that unit circle I gave you guys a while ago. Hello?
Hello. 3 pi over 2.
The x value.
Oh, I'm sorry. Pi.
So it's at pi, right?
Yeah.
So theta is going to be pi. Here, theta equals pi. Okay, let's do the same thing over here. So 0 equals 2 cosine theta minus 1. Add 1 to both sides. 1 equals 2 cosine theta. Divide by 2. 1/2 equals cosine theta. And now I have to do inverse again. So it's going to be theta equals inverse cosine of 1/2. So where is cosine equal to 1/2? There's two places for this.
Pi over 3 and 5 pi over 3.
Okay, pi over 3 and 5 pi over 3. So, but what was my interval? From where to where?
From 0 to pi over 2.
Very good. 0 to pi over 2. So since there was two places that my theta is going to be, my cosine is going to be a positive 1/2, right?
Yeah.
So I could throw out one of them because that's outside my interval. Can I also throw out the pi?
Yeah.
Is pi outside the interval? Say yes.
Yes.
Because my interval is only from 0 to pi over 2. So that's only quadrant 1, isn't it? Okay, so now this one right here, so theta was what?
Pi over 3.
pi over 3. Now, what that actually means in plain English. I did all this math. Did a lot of math. Okay, find the angle that maximizes the area. So what that means is the maximum area is going to be when theta is pi over 3. So I'm going to show you guys now to prove my point. I'm going to go, where's my... Okay, make sure it's in radian. Right here, I'm going to go, it was 16 cosine, right? No, 16 sine x, close, open, cosine, right? Cosine plus 1 right here. And where's my interval?
0.
So change my window. It's going to be from 0, pi over 2, pi over 2, let me zoom out. There we go. So right here, this is going to be the max right here. So menu, analyze, let's go trace, graph, and I want pi over 3, right? Pi divided by 3, enter. There it is. I got my maximum right there. All right, that's what it means. Don't forget, like, subscribe,
Yes. No.
notifications.